Hop on board. Hurry, we don't have much time. We're on a cosmic journey to find the biggest star in the universe. The first star we pass is our own sun. By far, not the biggest one out there, but it's still massive. You could fit 1 million Earths inside it. That means if you think of the sun like a basketball, Earth would be half the size of a pencil eraser. If we put all the planets on one side of a scale and the sun on the other, the planets wouldn't stand a chance. The sun makes up 99.9% of all the mass in the entire solar system. Mass is basically how much stuff or matter something is made from, and it's what you can thank for stars shining. You see, the more matter in a star, the thicker and hotter its core becomes. This starts a chain of chemical reactions. Hydrogen atoms get smashed into each other to form helium, releasing an incredible amount of energy. That's the star's light and heat. So, bigger stars also equal brighter ones. But with all those reactions going on, this shortens a star's lifespan. When it starts to run out of fuel, the star will enter the giant phase. It'll expand and turn red. Which brings us back to the task at hand. The biggest star we'll find is likely to be on the edge of its life. Switching on our hyper light engines, we soon arrive at the Luminous 16 system. Here, we'll find one of the smallest stars out there, a brown dwarf. Small here means about the size of Jupiter, but they're small for stars. Brown dwarfs are also called failed stars because they don't have enough mass for those chemical reactions. That means they're not as bright, but they're super dense. All the matter in them is packed together so tightly, they weigh 80 times more than Jupiter, even being the same size. And if you think that's something, just look at a white dwarf, even more tightly packed. This one here is Sirius B. It's also about the size of Jupiter, but it'd weigh as much as the sun. It emits a dim white light. Once it runs out of gas, it'll turn red and cool down. Now let's fly closer to its giant neighbor, Sirius A. You easily see this star from Earth. No telescope needed. Twice heavier and more than 1.5 times wider than our sun. It's the brightest star in our night sky. Now we fly 550 light-years away from Earth to the constellation Cassiopeia. Almost 100 years ago, a cosmic explosion happened here. It expanded the atmosphere of the star Gamma Cassiopeia, and some gases were thrown into space. After that, it became the brightest star in the constellation. It's 10 times wider than our sun. On to the famous North Star. Funny enough, different stars have had this title over the years, and more will take it in the future. That's because Earth's pole star changes every 26,000 years. Imagine our planet like a spinning top. The northern pole will shift around in a little circle, pointing at different stars to the true north. The current one is a supergiant 37 times wider and 5 times heavier than our sun. It's easy to find in the night sky. It's on the very tip of the Little Dipper's handle. Get ready now. We're setting off for the eye of the storm, the center of our Milky Way galaxy. To see the next star, we need to switch to infrared mode. This pistol star is hiding from us in space dust. In just 20 seconds, it emits as much light as our home star does in an entire year. And its size is jaw-dropping. It's 420 times wider than the sun. But it's still not the most luminous star known to humanity. That would be a blue supergiant in the constellation Triangulum. Meet B416. It's almost 10 million times brighter than the sun. But the brighter a star, the faster it burns up all its fuel, and the shorter its life. Compared with a red dwarf that barely glows and burns fuel much more slowly, its life will be hundreds of thousands of times shorter. 3,400 light-years from Earth, there's one of the rarest celestial bodies in the universe. It's a yellow hypergiant called Rho Cassiopeia. Among the countless stars in our galaxy, there are only a couple dozen of these. And even though this star is extremely far away from our planet, you can still see it in the sky without needing a telescope. That's because it's 300,000 times brighter than our sun. It also helps that the thing is 900 times wider than our home star, too. And its color tells us that its fuel reserves will last for a long time. When Rho Cassiopeia starts to turn red and expand, it'll be one of the biggest stars in the entire universe. Now, we move to the constellation Orion. The star is in our sights. Betelgeuse, one of the largest ones visible to the unaided eye. 700 times the size of our sun. If it took our star's place, its surface would touch the asteroid belt. That's between the orbits of Jupiter and Mars. It would engulf the 4 inner planets, Earth included. But this star has astronomers very excited. They predict Betelgeuse will explode in a fantastic celestial show in the next 10,000 years. It'll be the greatest astronomical event of all time because we'll be able to observe a supernova at a close but safe enough distance. The exploding star will shine as bright as a half moon. It'll be visible in the daytime sky for a year and at night for several more. Now we venture to stars that exceed the sun's width 1,000 times. Mu Cephei is a hypergiant boasting the title of the reddest known star. Its color tells us that the fuel gauge is getting closer and closer to empty, but it's still so big that it could hold 1 billion suns in it. And because of its mass, this star will eventually become a supernova or even a black hole. Let's take a trip of almost 4,000 light years from home. Here it is, a red supergiant called VY Canis Majoris. It's one of the biggest and brightest stars of the Milky Way. It could fit 3 billion suns. And even though it's so huge, this thing is surprisingly light, only 17 weights of the sun. In the context of celestial bodies, you could call this star an inflated balloon. In the next 100,000 years, VY Canis Majoris will explode in a hypernova. Gamma radiation will destroy all life in the local part of the universe. But this star is so far from our solar system that it wouldn't mean any harm to us. If we placed MY Cephei in the center of our solar system, it would bulge all the way out to Saturn's orbit. To remind you just how far away Saturn is, think of it this way. It takes the sun's light 8 minutes to reach Earth. To get to Saturn, it takes well over an hour. Compared to this massive star, the sun is just a grain of sand. It's one of the most luminous and reddest stars in our universe. The bigger and redder the star, the closer it is to its end. So, we're not looking at just a titan of the universe, but also one of the oldest celestial bodies out there. The second biggest star in the universe is UY Scuti. It's about 1.5 billion miles wide, 16 times the distance from the Earth to the Sun. This is a pulsating variable star. Its brightness changes about every 2 years. UY Scuti is a record breaker in fuel combustion per year. Scientists expect it to evolve back to hotter temperatures like a yellow giant. Our journey is coming to an end. Before us, we behold Stephenson 218. It takes 20,000 years for light from this star to reach Earth. It's hard not to see this red supergiant on our tiny terrestrial home. It's 2,150 times wider than our sun. We'd need 10 billion suns to fill its volume. For comparison, the average beach contains only about 5 billion grains of sand.
What would it be like to live on a planet traveling around a star so huge that, in comparison to it, our sun looks like a tiny speck of dust? Well, you could find it out if you manage to visit a planet orbiting WOH G64. It's a red supergiant, an enormous star dwelling in the Large Magellanic Cloud, which is a satellite galaxy located not too far away from our home Milky Way galaxy. Red supergiants in the Large and Small Magellanic Clouds provide an excellent opportunity to observationally test the current stellar evolution theory for massive stars. WOH G64 is likely the largest star we have found so far. It's a real heavyweight emitting an incredibly bright light. To understand the sheer size of this megastar better, let's put it into perspective. Compared to our star, the radius of WOH G64 is around 1,540 times bigger. In other words, it's like comparing a tiny grain of sand to a basketball. If we placed WOH G64 at the center of the solar system, the surface of this star would extend past the orbit of Jupiter, swallowing up Mercury, Venus, Earth, Mars, and Jupiter itself. You see, the average radius of Jupiter's orbit is around 1,000 times the radius of the Sun. As for Saturn, the radius of its orbit is around 2,000 times the radius of the Sun. That's why WOH G64, with its average radius being 1,500 times the radius of the Sun, fits right in between. Oh, and if you spread out the star's dust envelope, it would cover a distance of about 1 light year, or 5.88 trillion miles. The star is not only ginormous, but also immensely bright. In fact, it's one of the most luminous stars we know of. Luminosity is the total amount of energy a star emits per unit of time. And the light coming from WOH G64 is around 282,000 times brighter than the light from our Sun. But perhaps one of the most amazing features of WOH G64 is the dust envelope surrounding it. In 2007, astronomers, with the help of the Very Large Telescope, discovered that WOH G64 was surrounded by a torus-shaped cloud. It's so thick that to some extent it obscures the star. The dust envelope is made up of the material the star has expelled, and it contains between 3 to 9 times the mass of the Sun. The star we're talking about was discovered in the 1970s by Bengt Westerlund, Olander, and Hayden. That's where the WOH in the name of the star comes from. It's an abbreviation made up of the first letters of the discoverers' names. By the way, Westerlund also discovered another remarkable red supergiant, Westerlund 126. It was spotted in a massive star cluster called Westerlund 1 in the constellation of Ara. But back to WOH G64. Scientists have noted that this star lies very close to or even beyond the Hayashi limit. It is a theoretical constraint upon the maximum radius of a star for a given mass, a condition where the inward force of gravity is matched by the outward pressure of the gas. By now, the star WOH G64 has reached such an evolved state that it can no longer hold onto its atmosphere because of super low density, high radiation pressure, and relatively opaque products of thermonuclear fusion. That's why its average mass loss is among the highest known to us so far. It's unusually high even for a red supergiant. WOH G64 also shows an unexpected spectrum of nebular emissions. The hot gas is rich in nitrogen and has a radial velocity more positive than that of the star, which is quite an unusual phenomenon. The star might have a potential companion, an O-type main sequence star. If it turns out to be true, then WOH G64 will be classified as a binary star. At the same time, so far, there have been no confirmations of this theory, partly because the intervening dust clouds make the examination of the star very difficult. In any case, WOH G64 is absolutely fascinating, not only because of its huge size, but also because of its unbelievable luminosity and mysterious dust envelope. It's a great example of how unexpected and amazing our universe can get. Besides, such outstanding large stars are undoubtedly an important astronomical observation. The results of studies of such objects correct the restrictions on the properties of stars within the framework of modern models. For testing the applicability of models, the exceptions to the rules are most valuable.
A powerful burst of gamma radiation lasted a mere half-second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Astronomers examined the phenomenon with X-ray, radio, optical, and infrared waves. It turned out that people had finally seen a newborn magnetar for the first time ever. It was likely formed after 2 neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22nd, 2020. Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of its nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1,000,000 times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the Sun, it's likely to turn into a black hole. If not, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our Sun is almost 865,000 miles across, which is 109 Earths put side by side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our Sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. It's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When two neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's a rare form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. Even your molecules would change under the influence of the star's field. In the end, you'd pretty much vanish. If a magnetar flew within 100,000 miles from our planet, it would wipe out all the data on every single credit card in the world.
Check out this interstellar showstopper. Shadows doing a little dance in space have spilled the beans on a mind-boggling secret about our solar system's origins. There's a star, called TW Hydrae, that's playing host to some mischievous disks that are out of sync, spinning at slightly wonky angles. But what's causing this celestial chaos? Well, it seems like a bunch of baby planets are misbehaving, tugging at the disks with their gravity and throwing everything off balance. Hold on tight, because things are about to get even more interesting. This star is a real newbie in the cosmic neighborhood at just 8 million years old. Yep, that's practically a cosmic toddler compared to the ancient Sun, which has been around for a whopping 4.6 billion years. This new start hasn't even started its hydrogen-burning season yet. It's still in the process of growing and compacting under its own gravitational pull. Think of it as the Sun's younger doppelganger. Here's the lowdown on how stars like TW Hydrae get their groove on. They gather cosmic dust and gas from their surroundings, which forms a swirling disk around them. This disk is like a cosmic buffet for planet formation. Little specks of matter come together, forming bigger and bigger clumps that eventually collide and grow into full-fledged planets. Since they're born from a flat disk, these planets usually end up orbiting their star in a neat, flat plane. Now, our new star has struck gold with its unique orientation. We're lucky enough to have a front-row seat to this cosmic construction site because we can see the disk face on. And guess what? It looks a lot like our solar system. This gives us a chance to uncover some juicy secrets about our own planetary origins. Back in 2017, eagle-eyed astronomers noticed a shadow making its way around this new star's disk. It completed a full rotation every 16 years. Initially, they thought this shadow might be evidence of a sneaky young planet forming within the disk, causing parts of it to wobble in different directions. Fast forward to 2021, and things took an unexpected twist. The shadow did something totally unexpected, leaving everyone scratching their heads. Hold your horses, though. The savvy team of astronomers didn't give up easily. They put their thinking caps on and came up with a few possible explanations. After extensive modeling, they hit the jackpot. It turns out not just one, but two wobbly disks were at play, casting shadows on a third outer disk. This suggests the existence of a second young planet, making it a cosmic double feature. Imagine these two planets zooming around, one trying to outpace the other, like a pair of racing cars. The data suggests that the first disk is about 5 to 6 astronomical units from the star, while the second disk is around 6 to 7 astronomical units away. For reference, our mighty Jupiter orbits the Sun at a distance of 5.2 astronomical units. So, it's like a cosmic game of tag with the planets influencing each other's orbits. As these planetary misfits go about their orbits, their gravitational interplay causes the disks to tilt slightly with respect to one another. This creates shadows that dim the outer regions of the disk. Oh, and by the way, this totally matches our own solar system vibe. Why? Because some of the planets in our own solar system are rebels too, and have orbital inclinations that vary by up to 7 degrees. I'm looking at you, Mercury. Or a whopping 17 degrees if you count our dear friend Pluto. Who knows? If we continue researching this new star, it might just spill the beans on how our own solar system's got its funky orbital inclinations. How exactly do we define our solar system, though? It's like a celestial neighborhood with 8 funky planets happily orbiting our sun. In order of proximity to the sun, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Oh, and we can't forget Pluto, our little dwarf planet friend who used to be part of the Planet Club. Our solar system is way more than just the sum of its planets. It's like a fantastical mashup of asteroids, comets, stars, moons, and a whole bunch of other spacey stuff that makes our cosmic home truly enchanting. Contrary to popular belief, the hottest planet isn't the one getting all cozy next to the sun. Nope. It's Venus, the second closest planet. How come, you might ask? Well, Venus is scorching because it has an ultra-thick atmosphere. It's basically like it's wearing 100 layers of sweaters. When sunlight pierces through this super dense atmosphere, it turns Venus into a fiery furnace. We've also got some rocks on Earth that are like interplanetary tourists from Mars. Can you believe it? Scientists have found these rocks here, and they're chock full of the same gassy goodness found on the red planet. How did they get here? The most plausible scenario is that Mars sent a souvenir package through an asteroid crash or volcanic fireworks show. Our planet is also the ultimate chemistry whiz. Sure, other planets have bits and pieces of the elements we have, but we've got the whole shebang. Iron, oxygen, silicon, sulfur, magnesium, sodium, nickel, calcium, aluminum, if you can name it, we most likely have it here somewhere. Other planets are like, hey, we're mostly rock with helium and hydrogen, but we're here with our unique blend of interstellar awesomeness. Jupiter, however, the heavyweight champ of our solar system, has a never-ending party happening in its atmosphere. It's called the Great Red Spot, and it's been swirling with hurricane-like intensity for more than 300 years. This stormy event boasts extremely powerful winds, reaching a blazing 270 miles per hour. Oh, and by the way, this colossal storm is more than twice the size of our entire Earth. Neptune, on the other hand, knows how to make an entrance. It's got the fastest wind speeds in the solar system, zipping around at more than 1,200 miles per hour. Just like Jupiter and Saturn, Neptune actually produces more energy than it gets from the sun. As it turns out, Neptune's energy comes from its core, and that's what powers its super-duper strong winds on the surface. Now you might be wondering, how does Neptune manage to keep all that energy to itself? Well, it's all thanks to a special blanket of methane gas, which acts like a cosmic snuggie. This snuggie, or rather greenhouse gas, traps the heat and keeps it cozy on the planet. If Neptune were a bit more like Uranus, which is a bit of a slacker in the energy department, all that heat would have gone on a space vacation ages ago. Despite the chilly temperatures, Neptune doesn't let it bring down its funky style. It radiates a whopping 2.7 times more heat than it receives from the sun. It's like Neptune saying, hey sun, you're cool, but I've got enough heat to make my winds wild and crazy. Space isn't as far away as you might imagine. The Kármán line, which is approximately 62 miles above Earth, is like the official starting point of space. If you could drive your car straight up into the sky, you'd actually reach that mark in less than an hour. That's even quicker than some people's daily commute. As it turns out, our solar system is actually already halfway through its estimated life cycle. Scientists estimate that our solar system is around 4.6 billion years old, and it's expected to keep going strong for another 5 billion years. We've still got a lot of time left in this celestial ride. In the meantime, the Sun, our fiery superstar, will keep trying to pull the planets towards it. Talk about being clingy. Gravity on the Sun is so powerful that it's constantly exerting its pull. But don't worry, the planets are not just passive participants. They're like determined tug-of-war players, pulling in the opposite direction and keeping a fine balance. As a result, the planets end up kind of floating in the middle. It's no wonder the Sun has so much power around here. The mass of the Sun is mind-blowingly huge. In fact, the Sun's mass is around 330,000 times that of our beloved Earth, and get this, it accounts for over 99% of the total mass in our solar system.
Hey, look at this blazing monster. It's a white dwarf. These stars are known for gobbling up passing objects, and one day, these objects might be the planets of our own solar system. According to a new study, parts of the solar system will be pulled into a white dwarf star, crushed up, and eventually ground into a fine dust like coffee beans in a blade grinder. Hey, you like that analogy? Now, white dwarfs are a final stage of a star's life. It's a small but very dense star that's typically the size of a planet, the result of a low-mass star exhausting all the nuclear fuel in its center and losing its outer layers as a planetary nebula. When our Sun turns into a white dwarf, and it is bound to happen sometime, it'll destroy the asteroids and moons around Mars and Jupiter. They will be pulverized by its gravity. Earth, though, will be swallowed up even before the Sun turns into a white dwarf. But it won't happen for another 6 billion years. Researchers working on this topic have come to such conclusions by observing what happened to space bodies, asteroids, moons, and planets that were passing close to 3 white dwarfs. For 17 years, they observed and analyzed transits. That's when the brightness of a white dwarf dips because of an object in a stable orbit passing in front of it. In the case of white dwarfs, we can predict such transits and use them to study the stars themselves and celestial objects passing by them. So, when something gets too close to a white dwarf star, the star's immense gravity rips it into smaller and smaller pieces of debris. The team also found out that transits of such debris are chaotic. Plus, this debris is oddly shaped, which means that it is being devoured further. The first white dwarf used for studying the transit process, this here guy, seems steady and well-behaved over the last few years. Well, until scientists found some evidence of a massive catastrophic event that occurred in 2010 or so. The next star dims irregularly every couple of months before brightening again. And the third dwarf star used to behave close to theoretical predictions. It had transits that varied in number, shapes, and depths. But the latest study has shown that the transits are now completely gone. And this indicates the unpredicted nature of transits. One minute you see them, the next, poof. The reason might be the chaotic environment they have to exist in. As for our own solar system, and our planet in general, its fate looks pretty sad. Earth will be swallowed by the expanding Sun, even before our star turns into a white dwarf. As for the rest of the solar system, located further from the Sun, some of the asteroids between Mars and Jupiter, as well as some of Jupiter's moons, will be destroyed later. Oh well, they're likely to get dislodged and travel too close to the white dwarf. Now, at the same time, astronomers aren't 100% sure that it's exactly what will happen with our solar system, so I guess we'll just have to wait and see, for like 6 billion years. Speaking of white dwarfs, scientists have recently found one that has a bizarre metallic scar on its surface. This blemish could have formed after the star ripped up and ate a tiny planet orbiting it. White dwarfs with traces of metal in their atmospheres aren't rare. These traces are left by planets falling into stars, affected by their gravity. Experts have long thought that such metal should be distributed evenly across the surface of such polluted white dwarfs. But a new study has discovered a white dwarf with a weird concentrated patch of metal. This star was monitored over a period of 2 months with the help of the Very Large Telescope in Chile. The researchers found an opaque patch of metal. It was located over one of the star's magnetic poles and blocked some of the star's light as it rotated. Based on this position, Astronomers concluded that the material could have been funneled into the star by its powerful magnetic field. This process is similar to one causing auroras on Earth, where charged particles follow the magnetic field to the surface. Now, the planet destroyed by the white dwarf was most likely very small, around the same size as asteroid Vesta in our solar system, which is a mere 326 miles across. Its debris is now prominently displayed on the host star's surface. It makes it easier for researchers to examine what the planet's geochemistry was before it was devoured. Such a study might even turn out to be one of the best ways to observe small worlds beyond the solar system, even if such a world has already met its demise. There might be many more scarred stars like this one. The one in question was the first, but probably not the last. Even better, astronomers have already discovered 2 white dwarfs that seem to have similar scars. Making repeat observations of such stars might help us unearth, pardon the pun, no, I meant to do that, unearth even more secrets and make more discoveries. Another bizarre white dwarf discovered not long ago seems to have stopped cooling due to the formation of internal crystals. It challenges existing theories on star aging and also questions the method of stellar age estimation. But scientists might have understood why it may be happening. White dwarfs are believed to be dead stars. They keep cooling down over time, and normally this process can't be reversed or paused. But in 2019, the European Space Agency's Gaia satellite discovered a number of white dwarf stars that had stopped cooling for more than 8 billion years. It might mean that some white dwarfs can generate a lot of extra energy, which is at odds with the classical dead star theory. At first, astronomers couldn't figure out how it might happen. But in the end, more than 97% of stars in the Milky Way galaxy turn into white dwarfs. Astronomers have long thought that such stars are at the end of their lives. After depleting their nuclear energy source, they stop producing heat and cool down. Eventually, the dense plasma in their insides freezes into a solid state and the star solidifies from inside out. The whole process can take billions of years. But the new research claims that in some white dwarfs, this dense plasma doesn't simply freeze. Instead, its solid crystals forming upon freezing become less dense than the liquid and start floating around. They displace the heavier liquid downward. The movement of heavier material toward the center of a white dwarf releases gravitational energy, and this energy is enough to interrupt the star's cooling process and halt it for billions of years. Now, this explanation actually matches all of the properties of the unusual white dwarf population. But this is the first time such a transport mechanism has been seen in any type of star. And that's incredibly exciting. A totally new astrophysical phenomenon. But why does it happen in some stars but not in others? It most likely depends on the composition of the star. You see, some white dwarf stars are formed by the merger of 2 different stars. When they collide and form a white dwarf, it changes the composition of the star, which allows the formation of floating crystals. So this discovery might mean that astronomers will have to review the ways they use to determine the age of stars. At the moment, white dwarfs are often used as age indicators. The cooler a white dwarf is, the older it's believed to be. But now, we already know about possible delays in the cooling process of some dwarfs. It makes the popular age determination method more unreliable. Some stars of a given temperature may be billions of years older than we previously thought. The recently uncovered transport mechanism within white dwarfs means that some of these stars can be shining as bright as normal for billions of years. This complicates age dating and the use of white dwarfs to reconstruct the formation of our galaxy. Hey, stay tuned. Betelgeuse, one of the biggest and brightest stars we've ever seen. It's both gorgeous and dangerous in a way you can't even imagine. This star is old, bloated, and unstable, like me. It can go supernova at any moment. And it hides a mystery our astronomers haven't managed to crack yet. Will it impact the future of our planet? Well, let's see. Betelgeuse is the bright red shoulder of Orion, the hunter in the sky. It's a red supergiant star, and by supergiant, I mean really giant. This star weighs somewhere between 15 and 20 suns, but it's so stretched out that if you dropped it in our solar system, it would reach all the way to Mars. Imagine our planet swallowed by a glowing, bloated ball of reddish fire. No thanks. As for the whole red giant thing, it means a star near the end of its life. When it runs out of hydrogen in its core, it starts burning hydrogen in a shell around it. This makes the star's outer layers puff up and cool down, so it looks much bigger, cooler, and red in color. Betelgeuse isn't exactly in peak health. Massive stars like this live fast and pass away while still young. Their lifetimes depend on a lot of factors: mass, spin, how much metal they've cooked up in their cores. But even on the generous side, they only last a few million years. On the tight side, maybe a few 100,000. For comparison, our 4.6 billion-year-old Sun has plenty of life left. And tiny red dwarfs can keep going for trillions of years. Trillions! The universe itself isn't even old enough for red dwarfs to start kicking the bucket. Betelgeuse has already burned through all of its hydrogen, and now it's running on helium. That's what made it swell up into a red giant in the first place. Back in 2019, the star suddenly dimmed so much it looked like it was about to explode. Astronomers around the world were super excited. They thought we were about to witness a supernova in real time. But the truth was far less dramatic. Betelgeuse didn't reach the end of its cosmic life. It had just coughed up giant clouds of dust and gas, which drifted in front of it and blocked the light. Later, astronomers seemed to figure out the reason for this thing. The star basically blew off a huge chunk of its own atmosphere into space. And it was massive. The chunk had several times the mass of our Moon, and that's about 400 billion times more material than our Sun throws out in one of its normal eruptions. Once that piece cooled down, it turned into a giant dust cloud. From Earth, that cloud blocked a lot of Betelgeuse's light, making it look like the star was fading. But that's not all. Betelgeuse usually has a steady rhythm. It gets brighter and dimmer every 400 days, almost like a heartbeat. After this outburst, that cycle seems to have stopped, or at least gone quiet for now. When a star is old and unstable, its life might become pure chaos. One moment it's burning hydrogen, the next helium. Sometimes it shuts down. The next day it roars back to life. Its outer layers are so stretched out that they almost seem to be independent and have a mind of their own. Plus, there are terrible secrets these stars can hide, and Betelgeuse has one of its own. For decades, astronomers suspected Betelgeuse might have a hidden companion star, but spotting it was nearly impossible. Why? Because Betelgeuse shines up to 14,000 times brighter than our Sun. Its glow basically drowns out anything nearby. On top of that, our planet's thick atmosphere makes stargazing tricky. Light from space gets blurred and distorted as it fights its way through the air. When the Great Dimming happened in 2019, the Hubble Space Telescope was able to watch it unfold from above the Earth's atmosphere. It managed to clear up fears that Betelgeuse was about to explode, but even Hubble couldn't see through the massive cloud of gas and dust the star had coughed out to check for a potential companion. That's when astrophysicist Steve Howell from NASA's Ames Research Center tried a different approach. He turned to the Gemini North Telescope on Mauna Kea in Hawaii. It's a massive ground-based observatory with a wide opening that lets in more light. Gemini's secret weapon is a high-resolution camera called the Alopecia Speckle Imager. Instead of taking one long exposure shot, it fires off thousands of ultra-short ones. It helps freeze the chaos caused by Earth's atmosphere. Later, computers stitch all those snapshots together, scrubbing away the turbulence and leaving behind crystal-clear images. So, Steve Howell and his team got down to work, convinced something had to be there. Something that had slipped through all the earlier searches. With the Alopecia camera, they finally had the tool sharp enough to catch it, if it really existed. Howell later admitted the odds were slim. And still, Howell's team finally caught what looks like a faint companion star hiding at the far edge of Betelgeuse's atmosphere. And the best part was that it showed up exactly where earlier astronomers had predicted it might be. Same spot, same distance, and even the same angle. It wasn't just a random flicker of light. It matched the map. Right now, the companion is still hiding too close to Betelgeuse's blinding glare to see clearly. But its orbit will eventually carry it farther out, away from the giant star's brightness. That moment will come in November 2027, and when it does, telescopes should finally get a clean look. Those follow-up observations will settle the question for good. Is this faint little star real, or just a data glitch? Oh, by the way, the companion star already has a name. Betelgeuse comes from Arabic and means the hand of Al-Jaza, a legendary figure drawn across the night sky by ancient stargazers. They saw her whole form, hands, feet, head, hair, all stitched together by the stars of Orion. So Howell thought it only fitting to continue the theme. He named the companion Sawara, which translates to her bracelet. One day, long into the future, Betelgeuse and Sawara will spiral together and merge. But with a companion star or not, Betelgeuse is old, tired, and basically running out of gas. The clock is ticking, and one day, sooner or later, it'll go supernova. And when it does, it'll be a cosmic fireworks show unlike anything we've ever seen. Based on what we know, its size, how fast it spins, the group of stars it was born with, and the metals in its atmosphere, astronomers guess that Betelgeuse could explode as a supernova in a few 100,000 years. But don't get too comfortable, it could happen tomorrow. Or maybe it already did. Remember, the star is 500 light-years away. That means the light we're seeing now left Betelgeuse many, many years ago. If it exploded a century ago, we wouldn't know it yet. The star might already be gone. But when we finally see it go supernova, it'll be a show like nothing else in human history. A supernova can outshine entire galaxies, and at this distance, Betelgeuse will be blinding. It could be visible even during the day, brighter than any planet and nearly as bright as the full moon. But unlike the full moon, it won't be a comfortable glowing disk. Betelgeuse will remain a tiny pinpoint in the sky, but staring at it might actually hurt your eyes. This brilliance will last for a few months before fading, as all supernovae do. And don't worry, it won't hurt us. Why? Well, as crazy as a supernova is, stars are really far apart. That's where the inverse square law comes in. The energy a star or supernova emits spreads out over space. Double the distance, and the energy per spot drops to a quarter. 10 times the distance, and you're only getting 1/100th of the energy. It's the same reason you can walk a few steps back from a campfire and go from roasting to freezing in seconds. Anyway, what happens next is out of our hands. Maybe Betelgeuse will keep wobbling along for thousands of years, or maybe tomorrow night it'll light up the sky like never before. Either way, the universe has a way of surprising us, and the future will show what this giant star has in store.
Buckle up, fellow space enthusiasts, because we're about to uncover the celestial secrets that have been unveiled this year. From giant stars to organic molecules, this year is going great for astronomers. So let's catch up on all the excitement you might have missed in 2023. First of all, we've discovered some real astral monsters. Imagine looking up at the night sky and seeing stars that are not just big, but absolutely enormous. Scientists have been using a special telescope called the James Webb Space Telescope to explore the early days of the universe. And during their adventure, scientists stumbled upon ancient stars that are 10,000 times bigger than our sun. Yes, you heard it right, 10,000 times. These giants of the stellar world were some of the very first stars ever to form in the universe, billions of years ago. Imagine a globular cluster as a massive cosmic crew, where each group consists of a whopping 100,000 to 1 million members. These clusters are like giant family gatherings, with all the stars being born around the same time. But what makes these newly discovered monsters so special? Well, their cores, or their central parts, are way hotter than what we see in stars today. Scientists think that this intense heat might be due to a lot of hydrogen burning at really high temperatures. It's like they're having a galactic barbecue party. Something fascinating happens in these globular clusters. The smaller stars crash into the supermassive ones and gain extra energy, like a power-up. But here's the twist. Most of these clusters are now getting old, and the supermassive stars disappeared a long time ago. We can only see hints of their existence in the clusters we observe today. Scientists study them by just the mysterious traces of their grand presence. The discovery of these monster stars is incredibly important for our understanding of the universe. If scientists can gather more evidence to confirm their existence, it would be a major breakthrough. It would help us learn more about globular clusters and how supermassive stars form in general. But that was only the first fascinating discovery of 2023. Although the next one is kinda sad. You know those beautiful rings that make Saturn look so fancy? Well, guess what? They might disappear in the not-so-distant future, astronomically speaking. NASA's Cassini mission, which explored Saturn from 2004 to 2017, gathered some fascinating data about the rings. During Cassini's grand finale, when it did some cool maneuvers between Saturn, scientists noticed something surprising. The rings were losing a lot of mass every second. Tons of it. That means this magnificent halo will only stick around for a few 100 million more years, at most. That may seem like a long time for humans, but in the grand scheme of the universe, it's just a blink of an eye. The important thing is that we've learned that huge rings like Saturn's don't last forever. They eventually fade away. Oh, well, at least you and I personally won't catch this moment. Scientists have a fun theory about what will happen when Saturn's rings disappear. They think that the other ice and gas giants in our solar system, like Uranus and Jupiter, might have once had massive rings too. But over time, those rings wore down and became more like the thin, wispy bands of asteroids like what Uranus has now. Saturn's rings are mostly made of ice, but they also have a sprinkling of rocky dust. This dust comes from asteroids and teeny tiny meteoroids crashing into the celestial objects and breaking apart. It's like a snowstorm of icy particles and space debris. The research also revealed that Saturn's rings appeared long after the planet itself formed. They were still forming when dinosaurs roamed the Earth. So, in terms of astronomical age, they're actually quite young, only a few 100 million years old. This discovery has got scientists all excited because it means something dramatic happened in Saturn's past to create this stunning icy disk. But this is a mystery waiting to be solved. Scientists want to figure out what exactly caused the rings to form and why they have such a breathtaking structure. Let's hope they'll figure it out. But moving on to something more optimistic, we have another exciting space news. Recently, scientists have been studying one of the most distant galaxies in the universe, and they found something amazing: organic molecules. The galaxy in question has a long name, SPT 041847. It's over 12 billion light-years away from our little blue planet. Can you even imagine that distance? It's the farthest galaxy ever known, where complex organic molecules have been found. That's why looking at this galaxy is like looking at something from when the universe was just a baby. We have no idea what this galaxy looks like now. The light that has reached us is what it looked like when the universe was only 1.5 billion years old. Imagine being able to see things from so far in the past. So what they found is something with a very complicated name: a polycyclic aromatic hydrocarbon molecule, or simply PAH molecule. You might be wondering, what in the world is that? Well, guess what? You can actually find these molecules right here on our planet. They can be in things like the smoke from car engines or even forest fires. PAH molecules are made up of chains of carbon atoms. And here's the super cool part. They're considered the basic building blocks for life. Imagine that. Life's building blocks. Those tiny carbon chains being discovered in a galaxy that's so far away. That's like finding a needle in a haystack. They also found out that gas floating around in that galaxy is filled with heavy elements. That's a big deal because it suggests that many stars have come and gone there, creating all these amazing elements. This means that this galaxy can be potentially rich in many other elements too. This discovery opens up a world of possibilities and raises so many exciting questions. How did these molecules form in a galaxy so distant? And since we're looking into the past, what could have happened to these organic molecules during this time? Could they have evolved into life? We're only scratching the surface of the incredible things waiting to be uncovered. By the way, if it's so far, how did scientists even manage to discover something like that? Well, they had the instrument called the James Webb Space Telescope. This fancy telescope was recently launched and has superpowers when it comes to observing the universe. So when the scientists were studying this faraway galaxy, they had a little problem. The light coming from those distant objects was so faint that it was hard to see or detect. But guess what? They had a brilliant idea to solve this. They used something called gravitational lensing, which is like a special power of nature's magnifying glass. Imagine two galaxies lining up perfectly, just like in a photo shoot. The light from the faraway galaxy, the background one, travels towards us. But on its journey, it passes through the foreground galaxy, which is like a giant space lens. And guess what? The foreground galaxy's gravity bends the light, just like a magnifying glass, making it bigger and brighter. It's like having a cosmic zoom lens for our telescopes. This bending of light creates a super cool shape called an Einstein ring. It's like a halo, or a ring of light surrounding the foreground galaxy, basically a nature's way of showing off its magical powers. With gravitational lensing and these beautiful Einstein rings, scientists can see distant objects more clearly and learn amazing things about the universe. And thanks to all that, they managed to uncover the hidden chemical interactions from the early galaxies. Isn't that incredible? The scientists are beyond excited about this discovery. They never expected to find such complex organic molecules in a galaxy that's incredibly distant. Who knows? Maybe this is just the beginning of a thrilling cosmic journey. So, keep your eyes on the stars, fellow space explorers. The universe is full of surprises, and who knows what other mind-blowing discoveries await us out there. Let's hope we'll learn even more in the future.